So we've got a question here. We're given some information about an investment, and we're asked to determine something about it. We're asked to find the future value. And that's kind of a new term for us, right? But future value is just a finance term that means the final value of an investment at the end of a certain amount of time. Right, so that's the amount value, the A, in our compound interest formula. Now, the next thing we have to figure out, and I know I kind of gave it away talking about the compound interest formula, but the first thing you have to determine in these kinds of questions is what kind of interest are we talking about? Because we've got two formulas to work with now. We've got simple interest and compound interest. Well, it's usually not very subtle, right? If a question wants you to use simple interest, it'll explicitly say calculate some value using simple interest. Or you'll have a situation like this where you see that word compounded in the question. Right? Anytime you see that should be a big red flag that this is a compound interest problem. Right? So once I've identified that, the next thing I always do, I get out the formula. Right? Just kind of write the formula down here so I've got it in front of me. Then I'm going to look at the variables, and I'm going to literally make a table that lists all of the variables in the formula. And then I'm going to go back to the question. We're going to read through it. And I'm going to start putting numbers from the question into the table. And I've got my fingers crossed that at the end of the day, I have values for every variable except for one. I should be able to solve for that one. Hopefully it's the one we were asked to find, and that's going to be our answer. All right, so we start reading through this. If you invest $1,200, right, that's the initial investment. That's the P in our formula. In an account earning 5%, right, 5%, that's the interest rate. That's R. But I'm never going to write 5% in. Anytime I see a percentage, the very first thing I do, I go ahead and convert it to a decimal. So I'm going to put 0.05. And this is going to be compounded monthly. There's 12 months per year. So that's going to be N. And we're going to do this over 1 year. So that's going to be T. So I have values for everything except for A. A is the final value of the account after the year is up. That's the future value that we were asked to find. So we should be in good shape here. All right, I'm going to take those numbers. I'm going to substitute them into the formula. And then I'm going to very carefully go to my calculator, put these numbers in, and the end result is going to be the future value of this account is $1,261.39, a little more than it was when we initially made the investment. Now, you need to be careful when you're doing these with your calculator. Right? If you do that bit inside the parentheses, that 1 plus 0.05 over 12, it comes out to this. Right? Now, I'll see a lot of students, the way they do this, they kind of try to do it in pieces. They do that bit inside the parentheses, then they'll write on the next line 1,200 times, let's say 1.004 to the 12th power. Then they'll do the exponent part, that's the next line, then they'll multiply by 1,200. And they think, well, I rounded this to 3 decimal places. 3 decimal places is usually good enough. Yeah, it usually is, but it may not be here. The issue is, when you did that rounding, it introduced a small error into that number. When you multiply numbers, errors get magnified. And with that 12 in the exponent, that means I have to multiply that number by itself 12 times. And that's going to make that error a little bit bigger every time I do it. Right? And in the end, it can make a noticeable difference. I went ahead and did the calculations using 1.004 instead, and I came up with this value here. Right? Now you may say, oh yeah, it's only $3, a little less than $3. That's not that much. But what if instead of a $1,200 loan, it had been a $250,000 home loan? All right, then we would have been multiplying by a much bigger number than that 1,200. The error would have gotten magnified some more. Right? So, how do you fix this? Right? How do you get around it? Well, the way I do this is don't do it in parts. Enter the entire expression into your calculator all in one line, then hit the equal sign. And I've actually kind of worked that out for you here. This is how I would enter this into my calculator. I would do 1,200, the times key, parentheses, 1 plus 0.05, the divide key, and so on. Your calculator may do the exponent a little differently, but then you do the exponent and you hit the equal sign, so there's no rounding at all until the absolute very end when you round it to the nearest penny, and you should get the exact result that way. So if you'd like to see the context, you can click on the upper link here. That'll take you to the lecture on compound interest, or you can click on the link below that one, and that'll take you to the next example where we take a look at how to calculate the interest earned rather than the future value. And of course, if you like this video, please don't forget to click on the like button down below as well.